Hi students, good morning. Today we are going to discuss about a new chapter that is redox reaction. Let us go through that. Okay, so first of all, we want to understand what is a redox reaction, right? What is a redox reaction? A redox reaction is a reaction in which both oxidation and reduction taking place. That is called a redox reaction. What is a redox reaction? In that particular reaction, there must be simultaneously oxidation and reduction reaction. Okay, taking place. Okay, now let us see the different definition for oxidation and reduction. Now let us first discuss the definition in terms of oxygen. So what is the definition in terms of oxygen? Oxidation is the addition of oxygen to an element or a compound. So the opposite will be reduction. What is reduction? Reduction is the removal of an oxygen from an element or a compound. Understand? Let us see the examples. So we will understand more from the example. Okay, look at this particular example. Iron oxide is reacting with the carbon monoxide. Look at this example. Here, iron oxide is reacting with the carbon monoxide. So, when it reacts with carbon monoxide, what is happening to Fe2O3? It's removing the oxygen and converting into Fe, right? Fe2O3 is removing oxygen during this reaction and it is converting into Fe. So that the removal of oxygen is reduction. So this reaction, that is Fe2O3 to Fe, that is called reduction. And in this case of carbon monoxide, what is happening? Carbon monoxide is getting one oxygen and it is converting into carbon dioxide. One more oxygen it is getting. So that reaction is called oxidation. So this reaction entirely is called redox reaction because simultaneously reduction and oxidation is taking place. Okay, that is the reason. Now, one more thing you have to understand. If this particular compound is undergoing reduction, this will act as an oxidizing agent. Okay, oxidizing agent. Oppositive thing. Those which is undergoing reduction will be acting as an oxidizing agent. Those which is undergoing oxidation will be acting as a reducing agent. What is the reason? It is an oxidizing agent because this is the one which is giving oxygen to carbon monoxide. That is the reason why it is acting as an oxidizing agent. It is undergoing reduction and giving this oxygen to another compound so that it is acting as an oxidizing agent. Clear? So those which is undergoing reduction will act as an oxidizing agent. Those which is undergoing oxidation will be acting as the reducing agent. Okay, yes, and let us see the next case now. Another example, let us see. This is another example in which also oxidation and reduction reaction is taking place. Okay, look at this reaction. Here, copper oxide is reacting with magnesium. So, copper oxide is removing its oxygen during the reaction so that it is reduction, and magnesium is getting oxygen during the reaction. So, this is oxidation. Since it is undergoing both oxidation and reduction, this is called a redox reaction. Okay, and not only that, this copper oxide is undergoing reduction, so this is acting as an oxidizing agent. Magnesium is undergoing oxidation, so this is acting as a reducing agent. Clear? So now let us see the next reaction. Next example, that is with the zinc. Okay, so what is happening here? Zinc is reacting with the lead oxide. Similar reaction. So in this case, zinc is gaining oxygen so that it is oxidation. Lead is losing oxygen so that it is reduction. Since zinc undergo oxidation, it is acting as a reducing agent. Since lead oxide undergo reduction, this will acting as a oxidizing agent. Okay, those which is undergoing oxidation will act as reducing agent. Those which is undergoing reduction will be acting as a oxidizing agent. Okay, so that is the case in which another example also we can see. Here, iron oxide is reacting with the aluminium. Okay, so iron is losing oxygen and it is converting into Fe, so it is reduction. Aluminium is gaining oxygen so that it is undergoing oxidation. Fe2O3, since it is undergoing reduction, it will act as an oxidizing agent. Aluminium, since it is undergoing iron oxide, since it is undergoing reduction, it will be acting as an oxidizing agent. Aluminium, since it is undergoing oxidation, will act as a reducing agent. Okay. So now let us see the definition in terms of hydrogen. So what is in terms of hydrogen? Oxidation is the removal of hydrogen, opposite. Okay, in the case of oxygen, we learned the removal of oxygen is reduction. But here, oxidation is the removal of hydrogen and reduction is the addition of a hydrogen to an element or a compound. Let us see the example. So here is one of the example, that is ammonia is reacting with the Br2. So what is happening here? NH3 is losing hydrogen so that it is undergoing oxidation. Br2 is getting hydrogen so that is it is undergoing reduction. Since it is undergoing oxidation, this is acting as a reducing agent. Since it is undergoing reduction, it is acting as an oxidizing agent. Okay. Now let us see another example of this. Another example of this is hydrogen sulfide when react with the chlorine. What is happening there? Look at this. H2S is removing hydrogen and undergoing oxidation. Chlorine is gaining hydrogen and undergoing reduction. Since it is undergoing oxidation, it is acting as reducing agent. Since it is undergoing reduction, it is acting as oxidizing agent. Okay. So next, another example is there. Let us see the another example that is already discussed. Okay, now let us see in terms of electronegativity and electropositivity, how can we define oxidation and reduction? Oxidation is the addition of electronegative element to a substance, and reduction is the removal of hydrogen or electropositive element from a substance. So addition of electropositive, it is the addition of addition. It is the addition of electronegative element to a substance, and it is the removal of electropositive element from a substance. Okay, now let us see that example also. So here it is, all of this is undergoing oxidation because magnesium is reacting with electronegative element. So it is an oxidation. Here also it is oxidation, electronegative element chlorine, electronegative element sulfur. So this all are considered as oxidation and this is considered as reduction. Metals are electropositive. Since it is removing one metal from this complex, it becomes K3, so that it is considered as a reduction reaction. So redox reaction, now in terms of electron transfer, that is very important. Okay. Reaction that involve loss of electrons are called oxidation reaction, and reaction that involve gain of electrons are called a reduction reactions. Okay, reaction that involve loss of electrons are called oxidation and gain of electron is called a reduction reaction. Okay, let us see the examples. So in this case, let us see this particular case. In this case, what is happening? Copper is having 2+. Mg means if it is in an elemental form, that indicate that it is neutral, no charge for this. This is also elemental form, no charge. So Mg2+. So CO2+ is converting into Cu. So here Cu2+, we can write Cu2+ is converting into Cu. How Cu2+ will be converting into Cu? By the addition of 2 electron. When it adds 2 electron, it becomes, because 2+ means it is in lack of 2 electrons. So when you add 2 electron, it becomes copper. Okay. So this is what this is called a reduction, because it is adding electron here. So if you see Mg is converting into Mg2+, means how Mg2+? By removal of a two electron only it is possible. So Mg will remove two electron. Since it is removal of electron, it is called oxidation. Okay. So this is oxidation, this is reduction. So here we can see one more thing. We can explain oxidation and reduction in terms of oxidation number also. So how can we tell in terms of oxidation number? So look at this oxidation number of copper. If there is a decrease in oxidation number, that is 2 plus 2 0. If there is a decrease in oxidation number, that is called a reduction. If there is an increase in oxidation number, and that reaction is called oxidation. Okay. If there is a decrease in oxidation number, that is reduction. If there is an increase in oxidation number, that is oxidation. So this is undergoing reduction. So it is acting as an oxidizing agent, and this is undergoing oxidation. So it is acting as a reducing agent. Okay, clear? Now, let us see now next case. Look at this particular example. When Mg is reacting with the oxygen, what is happening? It is in the elemental form. Elemental form, all is they are neutral, no charge. Okay. So in the compound form, that is MgO. This is the compound. In MgO, Mg is existing as 2 plus and O is existing as 2 minus. In ionic bonding and all we are learning, magnesium is giving 2 electron to oxygen and oxygen is gaining 2 electron and forming the ionic bond. So Mg is having 2 plus oxidation number, oxygen is having 2 minus. So in terms of oxidation number, it is very easy to tell this is an oxidation reaction and this is a reduction reaction, since there is an increase and decrease of oxidation number here. So in terms of electron, how can we explain? Mg is converting into Mg2 plus. So how it will be converting into 2 plus? By removal of 2 electrons. So this is considered as what? This is considered as oxidation. So this reaction is considered as oxidation. Now O2 is converting into O2 minus, to O2 minus. Okay. So how it is possible? It is possible only by addition of 2 electrons. Since there are 4 oxygen, 2 oxygen, 4 electron you have to add. So it become O2. By addition of electron, it will be converting into O2 minus. So this reaction is reduction. Okay. Now let us see another cases, examples. So this is another example. In this example, what is happening? Let us see it first. So in this particular example, sodium is converting into Na plus. So increase in oxidation number, or only by loss of Na is converting into Na plus only by the addition of electron, 1 electron, because there are 2 electron, here it is written 2 electron. Okay, so it is converting into Na plus, and Cl2, in order to convert Cl2 into 2Cl minus, each chlorine atom has to add 1 electron. So there are 2 chlorine atoms, so 2 electron you have to add. Understand that it is gain of electron. So it is loss of electron, so that it is oxidation. And it is gain of electron, so that it is reduction. Since it is undergoing oxidation, it is the reducing agent, and this is the oxidizing agent. Okay. And here also loss of electron. We can see that if the oxidation number is increasing, loss of electron. If the oxidation number is decreasing, then there is gain of electron. Okay. So this is considered as oxidation, and this is considered as reduction. Here also there is loss of electron from here to here. So it is oxidation, and here gain of electron. So it is considered as reduction. Okay. Now let us see. What do you mean by oxidizing agent? Already we discussed. The acceptor of electron is considered as oxidizing agent, and reducing agent means donor of electron. So no need to go for such a complication. That sodium is undergoing oxidation, and it will remove that the lost 2 electron that is providing to chlorine. Okay, so it is an electron donor, so that it is acting as a reducing agent. Okay, so oxidizing agent, acceptor of electron, and reducing agent, donor of electrons. Okay. Now competitive electron transfer reaction, so that we have already learned in 10th grade. So first we have to understand what is the electron, the reactivity series, how the metals are arranged in the reactivity series. So in the reactivity series, it is arranged like a highly reactive metal will be on the top. And if we are moving down, less reactive metal will be on the bottom side. Okay. So the most reactive metal on the top and least reactive metal will be on the bottom side. Okay. In the reactivity series. So here we are going to discuss about the metal displacement reaction. In metal displacement reaction, what is important is the most reactive metal displays the least reactive metal. Okay, displays the least reactive metal. So let us see the case. That case we can see here. Here you are going to put zinc in copper nitrate. Okay, zinc in copper nitrate here. So which is the most reactive here? Zinc. Let us see. Go back to the reactivity series and understand. If you see copper and zinc, where is copper and zinc? Zinc is on the top and copper is on the bottom. So top one is reactive, right? So here zinc is more reactive, copper is least reactive. So that what will happen? Is zinc. The zinc will displace the copper. So that what will happen? This becomes zinc nitrate, and you will be getting copper. Like this, the reaction will be taking place. So here you have to understand one thing. If you are putting zinc in copper nitrate, what is happening? The zinc is converting into zinc nitrate, right? Zinc nitrate is actually colorless. So we can see that the color fade, at last it become colorless because of the formation of zinc nitrate. And what will happen? Copper is forming. Where it will be forming? It will be depositing on the zinc rod. So you can see brown color on the zinc rod because it is going to deposit. So if you see the reaction, we can see that Seden is reacting with a Cu2 plus. Okay, that will give Seden 2 plus Cu. Okay, it was in the compound at first. That will be displaced by zinc, and zinc become Seden 2 plus, and Cu become elemental form Cu. Okay, so its oxidation number is increasing here, so it is considered as oxidation, and here it is decreasing, so it is considered as reduction. Okay. Yes. Now let us see another competitive reaction like this. This is another reaction in which copper rod is dipped in silver nitrate solution. Okay, copper rod dipped in silver nitrate solution. So copper plus silver nitrate, AgNO3 will be there. So that will be giving you CuNO3 because copper is more reactive than silver. So CuNO3 twice plus 2Ag. Okay, this is the reaction happening here. So here what is happening? If you are putting copper in silver nitrate solution, the copper will displace the silver and copper nitrate will form. So the color will reappear here. See, it was colorless, and because of the formation of copper nitrate, it becomes blue at the end. And what will happen to this copper rod? The copper rod becomes silvery color because silver is going to deposit on the copper rod. Okay. So that reaction also we can see how the reaction is taking place. This is the reaction copper plus silver. Okay. In this reaction, see, copper is losing electron and forming Cu2 plus. So it is actually oxidation, and Ag plus is converting into Ag. So this is decrease in oxidation number and gain of 2 electron. So that it is considered as reduction. Okay. Now another example is there. Before it was blue color, this is blue copper sulfate. So when blue copper sulfate, if you are putting iron nail, it become green in color. What is the reason? And the iron rod become, the copper metal will deposit over the iron metal. What is the reason? This is the reaction taking place when Fe is putting inside copper. So Fe will be displacing the copper, so that Fe become Fe2 plus and copper will form. See, this copper formed will deposit over iron. That is why brown color we are getting. And Fe super is having a green color. and copper is having a blue color. So blue color will become green color because of the formation of ferrous sulfate. Okay. Now let us see the rules. What is oxidation number? Oxidation number we can see in a metal, how many electron it is releasing or it is gaining is understanding from the oxidation number. Okay. If it is losing electron, it become negative. Positive, and if it is gaining electron, it become positive. That number, that is called a oxidation number. Oxidation number denote the oxidation state of an element in a compound. According to a set, it is ascertained according to a set of rules. That is what we are going to learn now. What are the set of rule that is ascertained to find out the oxidation number? Okay, so that is the thing we are going to find now. Okay, so first let us see the rules to determine the oxidation number. Okay, the first rule to determine the oxidation number is for an element. We already discussed that if you are considering an element, for an element always the oxidation number should be 0. For example, if you are considering the element like oxygen, hydrogen, oxygen, chlorine, O3P4S8, if they are existing, their oxidation number is considered as 0 because they are neutral. Okay, so oxidation number of an element is considered as 0. That is the first rule we have to learn. And the second rule, what is the second rule? For iron composed of only one atom, that is monoatomic iron like Cl minus, Br minus. So what is the number written here? That is its oxidation number, minus 1, oxygen 2 minus, this is the oxidation number. Okay. Alkali metals, if you are considering alkali metal, they have a tendency to lose electron, 1 electron always. So its oxidation number is like Na plus 1, okay, K plus 1. Its oxidation number is always plus 1. And alkaline earth metals are second group and they are also having a tendency to release 2 electrons. So their oxidation number is considered as plus 2. And third group, aluminium is a metal. Its oxidation number, it will release 3 electrons. So its oxidation number is plus 3. Okay. Now let us see the next rule. So usually the oxidation number of oxygen is considered as -2 because in most of the compounds its oxidation number is -2. But in peroxide, but in the case of peroxide like H2O2, Na2O2, etc., each oxygen atom is assigned an oxidation number of -1. Okay. It is having an oxidation number of -1. Let us see that. So if you are taking H2O2, hydrogen is +1 oxidation number. How we will understand the oxidation number? H2O2. So hydrogen is having +1 oxidation number, right? This is having -2 oxidation number. This is having +1 oxidation number, and this is having, we don't know what is oxidation number, so we are going to put X here. Okay, so this is +1. We know hydrogen is +1. So +1 into how many hydrogen is there? 2 hydrogen plus this one we don't know. So we put X into what? 2 is equal to, this is entirely the H2O2 is a neutral species. So its charge will be 0. So we can write 2 plus 2x equal to 0. Then 2x equal to what? -2. Then x equal to -2 by 2, that is equal to -1. In this way we are finding. So in the case of peroxide, what is the oxidation number? The oxidation number will be -1. In the case of superoxide like KO2, let us see K. We already know that the alkali metals are having +1 oxidation number. This we don't know, put X. So +1 into only one potassium plus 2 into X equal to 0. Okay, so +1 into 1 is 1 plus 2x equal to 0. So 2x equal to -1 and x is equal to -half. So in the case of superoxide, its oxidation number is considered as -half. When oxygen is bonded to fluorine, In such compounds, oxygen difluoride and dioxygen difluoride, it is having a positive oxidation number. Let us see that. That is OF2. This fluorine is always having -1 oxidation number. So oxygen is putting as X. So 2 into -1 plus X is equal to 0. So X is equal to what? 2 into -1 means it is -2 plus X. So X is equal to +2. Okay, so it is getting a +2 oxidation number. And for O2F2, we can see O2F2, we don't know what is this, and we know this is -1. So we will write 2 into X plus 2 into -1, total is equal to 0. So 2X minus 2 equal to 0, 2X equal to +2, X is equal to 2 by 2 is equal to +1. Okay, so the oxidation number become +1. So these are the different oxidation number of oxygen. -2 most common. In peroxide it is -1. In superoxide it is -half. With the fluorine it is having positive oxidation number +2 and +1. Okay. Now let us see the next rule. The oxidation number of hydrogen is always considered as +1. But when it is combining with the hydride, we already learned, it is combining with a metal like sodium. Metal is always electropositive. So that the metal will be, this will be always +1, but then that time it will be getting a -1 charge, because with the metal is most electropositive. So that with the metal, always the hydrogen is having a minus oxidation number. Okay. So now let us discuss about another important rule. The algebraic sum of the oxidation number of all atom in a compound must be 0. That we have already learned. Now HCl, if you are taking another example, HCl. So if you, the oxidation number, if you see, this is +1, this is -1. So when you add them together, the it will be 0, because it is a neutral species. Okay. So the sum of oxidation number should be 0 always. In polyatomic iron, like CO3 2-, what is the charge of 2-? This is the charge of that polyatomic ion. Okay. Yes. Now, let's see one more thing that is called a stock notation. Stock notation means sometime we will be introducing, or we will be representing the oxidation number of a metal by putting a Roman letter in bracket, okay, adjacent to the metal. So this is gold, aurum. Aurum is having oxidation number 1 when it is combining with the chlorine sometime. So that oxidation number in Roman letter adjacent to that metal we will be putting, that is called a stock notation. In this case, it's having 3, oxidation number is 3. So that is putting in Roman letter adjacent to the metal while writing the formula. That is called a stock notation. Okay, that's all for today. Thank you.